So we've looked at basic probability, which is just what you want to happen over what can happen. We've talked about independent and dependent, two different things happening, and sometimes one is dependent on the other. And today we're going to talk about conditional probability. So conditional probability is finding the probability of finding one event given that a second event has already occurred. And so it looks like this. You'll notice this notation. When you see that, that means given. What's the probability of A given B? And so what goes on top is what I want, which I want A and B to happen. And then on bottom is what can happen after we have restricted our sample size to just B, because given B has happened. So this is now what can happen and not the total. So what we're looking for is the overlap over the given part, because we've been looking at the total, but now we're going to take a big group of things and we're going to restrict our field of vision and only look at a piece of it. So let's look at what some of these questions can look like in a combination of what we've been doing before. So we've got a table here. We're going to do all of these with two-way tables. We've got triangles, rectangles. We have 12 triangles. We have 14 rectangles. We have 15 blue shapes, and we have 11 red shapes. So in all, we have 26 total shapes. So let's look at some questions with this. A student reaches into the basket and draws a shape. What is the probability that the shape is a triangle? That's all we want to know. We're looking at all of the shapes. We haven't restricted it to anything. We just want to know what's the probability that the shape, this whole table represents shapes, is a triangle. So that's going to be triangle over total, because we're looking at everything. So there are 12 triangles. There are 26 shapes, which is 6 over 13 in fractional probability, which then you can convert into decimal probability or percent probability, which is 46.2%. Okay, what is the probability that the shape is red? Again, we're looking at all of the shapes, but now I want to know what the probability is of getting a red shape. So on top, we're going to look for how many we have that are red, and on bottom, we're going to look at everything, all of the shapes. So in all, there are 11 red shapes, and there are 26 total. Well, 11 over 26 is a reduced fraction. You can convert that into decimals, or you can convert that into percent. This one is where I'm going to round to the nearest tenth, just to be consistent, that you can round to whatever you're supposed to round to. C says, what's the probability the shape is a red triangle? So this time, we're still looking at all of the shapes, but now we want red triangles. So now we want red triangles, not just red, but red triangles over total. What I want you to see, what I'm trying to get you to see, is how to read the questions and know how to answer it. So we had 5 red triangles out of the 26 shapes, which is 19.2%. Okay, and then the last one says if a triangle is selected at random. So we are only looking at triangles. If a triangle is selected at random, so only look at triangles. What is the fractional probability that the selected triangle is red? Okay, so what we're looking for on top is a red triangle. But what goes on bottom is just triangles, because I only wanted you to look at the triangles. I have already pulled out all the triangles. Now that I'm only looking at the triangles, what's the probability that it's red? So red triangles, there are 5 red triangles, and there are 12 triangles. So 5 over 12 is 41.7%. So this could also be worded, what's the probability of selecting a triangle, a red triangle, given the shape is a triangle? Or what's the probability of choosing a red given it's a triangle? That's another way that it could be worded. So that's what this looks like. What's the probability that it's red given that it's a triangle? Okay, so there's one example. Let's look at some more. We have ice cream shop. Okay, these kinds of things are good for people to know, distributors to know what they need to buy, companies to know what they need to buy. So we have a table with chocolate, vanilla, and twist. Let's total these all up. We have 180 orders that had sprinkles. We have 40 orders that don't have sprinkles, so obviously they need to stock up on sprinkles. We have 80 orders that were chocolate. We have 40 orders that were vanilla, and 100 orders that were twist. So in all, we have 220 orders that we're looking at. Okay, so what is the probability of an order of vanilla? So just out of all of the things they could order, what's the probability that they're going to order vanilla? So that's vanilla over total. Okay, well, there are 40 vanilla orders. Here's my vanilla. There were 40 vanilla orders out of 220 total orders. If you reduce 40 over 220, you get 21. Ooh, the number that I have is not right. Can't be 21 over 11, so let me look. 40 over 220. Yep, 2 over 11. 2 over 11. And that is 18.2%. Always make sure that you pay attention to what you have been asked to, how you've been asked to record your answers, just to be sure that you answer it the right way. It'd be a shame to get all the work the right way, but then not answer the answer the right way. What's the probability of an order having sprinkles? So again, we're looking at total orders. And this time I want to know how many have sprinkles. So we have 180 orders that have sprinkles out of the 220 orders in all. That reduces to 18 over 22, which reduces to 9 over 11. And that gives me 81.8%. So 82% of the orders include sprinkles. So that's definitely something that they're going to want to keep stock of. So let's complicate things a little bit. If a customer order is selected at random, what is the decimal probability of selecting an order with sprinkles given the flavor is vanilla? That right there is important. What is the probability of choosing an order with sprinkles given that it's vanilla? Okay, that's what that means, is given. Okay, so what that means is we're not looking at everything. We are looking at vanilla, only vanilla. So we want to restrict our table and only look at vanilla. So what we want is sprinkles plus vanilla over vanilla. Overlap what meets both requirements over the one requirement that we've taken it. So we took the whole group. Now we're just looking at vanilla orders. Now we want to know, do they order sprinkles and vanilla? So let's take a look. So sprinkles and vanilla, there are 30 sprinkles and vanilla, and there are 40 vanilla. That reduces to 0.75, which is decimal probability. I know these have decimals, but this is percent probability. This is decimal probability. So we would leave it like this. So that's decimal probability. Okay, let's do another one. Given the customer ordered chocolate or vanilla, okay, so again, we don't care which one they ordered, chocolate or vanilla. So we are going to look at chocolate or vanilla because we don't care which one. We're just going to take them both. Given that they ordered chocolate or vanilla, what is the probability that they chose sprinkles? So what we look for then is on top, we want sprinkles and chocolate and vanilla. Okay, it has to meet all of them. So we have sprinkles and chocolate and vanilla. So there were 60 chocolate with sprinkles and 30 vanilla with sprinkles. So I'm going to do 60 plus 30 over chocolate or vanilla. Chocolate or vanilla, there are 120 that were chocolate or vanilla. And we don't care which one, so we're going to include them both. So we're going to count total chocolate and vanilla. So I get, that's 80 plus 40. So now I have 90 over 120. which reduces to 9 over 12, which reduces to 3 over 4 if we wanted to leave it as fractional probability, which we'll just leave it like that, which is 75% again. Okay, so the important part is noticing how you're given and whether you're restricting and looking at all of them or you're looking at part of them. Okay, so let's do some more examples. You can work ahead of me if you want. Put this on pause and go try some yourself, but in the meantime, I'll keep going. So this table reports some information about hurricanes back in 97 to 2003. Some of them were in the Pacific, some of them were in the Atlantic, some of them were category 1 or 2, and some of them were categories 3, 4, and 5. So what is the probability that the hurricane during this time period is an Atlantic hurricane given it's a category 3 or greater? So we're going to look at these three. So actually we don't need this. We just want to know what's the probability of a hurricane during that time is, and then we don't want this. So let's look at this, is ... is in the Atlantic given that it's a category 3. This is my given. So I'm not looking at everybody. I am only looking at the category 3s, and then I'm going to look at the Atlantics from there. So given that it's a category 3, okay, so we're going to look right here, and this is all we're going to look at, okay? So now I want overlap, Atlantic and category 3. So now only in this column, we want Atlantic and category 3, okay? So what we're going to do is we're going to do Atlantic and category 3 over category 3. So Atlantic and category 3 is 21 over 24, and 21 adds up to 45. And 21 over 45 reduces to 7 over 15. And we'll just leave it like that. You can convert it to decimals or to percent. Now let's look at the other way around. So what if we do it backwards to that? What if now I want to look for what's the probability that it's a category 3 given that it's in the Atlantic? So we are only going to look at the Atlantic. So now we're going to look at this, only the Atlantic. So what's the probability that it's a cat 3 and in the Atlantic? So cat 3 and Atlantic, I wrote 3, over just Atlantic. Okay, given goes on bottom, overlap goes on top. Okay, so category 3 and Atlantic is 21 over Atlantic is 28 plus 21, which is a total of 49. And 21 over 49 reduces to 3 over 7. So you can see they're different, right? So what's the probability that it is, if I know it is a cat 3, what's the probability that it's Atlantic? If I know that it's in the Atlantic, what's the probability that it's a cat 3? It all depends on what you knew first when you started the problem. Okay, then the last one, what's the probability, so this one's different, there's no given. What's the probability that it's in the Atlantic and it's a category 3? Okay, I'm not restricting it. It's in the Atlantic and it's a category 3 out of all the hurricanes that happened during those years. Okay, well, that's Atlantic and category 3 over total. So now we're looking at total. I didn't restrict anything that I was looking at. I'm still looking at everybody. So Atlantic and category 3, there are 21 that are both in the Atlantic and category 3. So again, that 21 goes on top over total. Well, there are 54 in the Pacific, and which means there are 103 total. And 21 over 103 can't be reduced. Okay? So this I wanted you to see because you can see like they're very similar, right? We're using the same information, but you're getting different answers. So how you restrict it does matter. Okay, last one. The table below shows modes of transportation used by students. Okay, so we've got car, bus, and walk, and then we've got 9th through 12th grade, and I've already got the totals on there for you. Okay, so what is the probability that a student, any student, walks to school? Okay, so any student. Okay, so all we care about is the probability that they walk. So what we want is walk over total. Okay, well, there are 82 students in all that walk, and there are 745 students that we're looking at. So 82 over 745 is 0.110067 equals 11.0%, rounded to the nearest tenth of a percent. Okay, what's the probability of choosing a ninth grade student who walks to school? Now, we're still looking at, we want ninths and walks. Okay, so we want ninths and walks, so that's looking at a ninth grader who walks. There are 30 ninth graders who walk. Okay, so there's ninth and walk over total. We're still looking at everybody. So ninth and walk, there are 30 ninth graders who walk out of the 745 students in all. Okay, that is 0.04027, which is 4.0% rounded to the nearest tenth. Remember, move the decimal 2 places and then round to the nearest tenth after that. Don't round and then move the decimal. Move the decimal and then round. What's the probability that the student walks given they are in the ninth grade? Okay, so now we're not looking at everybody anymore. Now we are only looking at ninth grade. So let's look at ninth graders. And I want to know the probability that they walk. So let's look at ninth graders who walk. There are 30 ninth graders who walk. Okay, so there are 30 ninth graders who walk out of the 205 ninth graders. See, we're not looking at the whole table anymore. Now we're only looking, given they are in the ninth grade. So we've sifted through everybody. We've separated and said, ninth graders, go over there. And now we're going to choose from the ninth graders. So 30 over 205 is 0.14634. We move the decimal 2 places, and then we round to the nearest tenth. That is 14.6%. Okay, what's the probability that a student rides in a car? So we care about car, given that they are in 11th or 12th grade. So what we've said is, hey, all you students, if you're in 11th or 12th grade, go over there to the other side of the gym. So now we're looking at 11th and 12th grade, and we don't care which one they're in. They can be in 11th or 12th, because they can't be in both. But they can be in 11th or 12th. But we want to know the people who ride in a car. So there are 95 and 120 11th and 12th graders who ride in a car. Okay, so we're looking for 11 and 12 and car over 11 and 12. Okay, sorry, couldn't see that. So we're looking at 95 and 120, because we have 95 and 120 in the car column. So 95 and 120 over 11 and 12, there are 175 and 165. And we don't care which one, whether, because they can't be in both, like I said. So we don't care which one they're in, so we're going to include both of them in our group. 95 and 120 is 215. 175 and 165 is 340, which in decimal percent is, or in decimal probability is 0.6324. Move the decimal 2 places and then round, and you get 63.2%. And I'm just rounding to the nearest tenth of a percent, right? That can change depending on what you've been asked to do. All right, last one. What's the probability that the student is in 11th grade, given that they ride a bus? Given that they ride a bus. So now we've called everybody back to there, and we said, okay, if you ride a bus, go over there. So now we are only looking at the students who ride the bus. If we're only looking at the students, if we're only looking at those 297 students, what's the probability of choosing someone who's in 11th grade? Okay, so we want 11th grade and bus. So 11th grade and bus is 62. So we have 62 that were 11th grade and bus over the 297 that were on the bus, or that ride the bus. That is 62 over 297 in decimal probability is 0.20875, which when you move the decimal 2 places and then you round, you get 20.875 or 20.9%. Okay, so summary, what do we need? When it says given, okay, when it says given, what we're looking for is the overlap. What meets all the requirements that I want over what's the given part. And so what you have to distinguish is when do you use the total on the bottom and when do you use the given total on the bottom. And so just look for that key word. Look for the word given. Or it'll say, if this is the group you're looking at, it'll say something like that, like we did over here on the triangles. I said, if a triangle is selected at random. So if there's some restriction of what you're looking at, that's what you want to do. Okay? Overlap over given.